Okay, hi guys. So today we're gonna record on completing the square. I gave you this handout in class, so it's due tomorrow, Wednesday, during your class period. We're gonna watch a video on Flip Classroom, which you should have already done that. It's on our playlist, and then we're gonna complete the square. Our objective for today, I'm going to freeze this frame for now, so that way you can copy it down and I don't have to waste time recording it. So make sure you write down your name, your class period. Today's date is October 6, 2015, and our objective is to learn the step-by-step process of completing the square. Completing the square is a process of allowing us to make a perfect square trinomial that allows us to factor our quadratic function so that we can actually get the zeros or the roots from that function. So the essential question that you're answering today is, how can a student rewrite a quadratic function in standard form into vertex form? So today we were practicing in class with our flashboards how to go from a vertex form to a standard form. So tonight you're going to learn about how to go from standard into vertex. And the way that we're going to do that is by completing the square. Completing the square has a couple of steps. I want you to go ahead and freeze the frame so you can copy down the steps. So step 1 is to set your equation equal to 0. Step 2 is to move c, the letter c, in ax squared plus bx plus c. That's your constant. You're going to move it to the other side of the equation. I went ahead and added y equals to ax squared plus bx plus c at the top of your essential question so that you know what I'm talking about when I'm talking about c. You want to move c to the other side of the equation, and then you're going to divide each of your terms on both sides of the equation by the constant leading coefficient a. So you're simplifying your function into something a lot easier, okay? You want to get a leading coefficient of 1. Alright guys, so we went through steps 1, 2, and 3, and now it's time to put it into practice. So you're going to write y equals, that's your original problem. This is your example, x squared plus 6x minus 7. Okay, step 1 says to set your equation equal to 0. So I'm going to replace my y with a 0. That's step 1.
And then you move 7.
Okay. Yeah, we're going to move c, the constant, to the other side of the equation. Before we do that, I want you to go ahead and write down what a, b, and c are equal to. So that way there's no confusion about what the letter a and b stand for. A in this case is what?
1.
1. B is
6.
6. And c is
-7.
-7. You guys see that?
Yes, ma'am.
Okay, so I want to move c, or -7, to the other side of the equation. And how do we do that? How do we move?
You divide 7.
Yeah, you're going to add 7. You're going to do the opposite of what's being done, which is adding 7 to both sides of the equal sign. So now you have 0 plus 7 is 7, is equal to x squared plus 6x. -7 plus 7, it just disappears. You're left with 0, and we don't really write 0. The next step is to divide all numbers on both sides of the equation by a. In this case, a is, this is step 2, and then step 3 is to divide all sides by the letter a. Okay, what is the letter a in this case?
1.
1. So I'm going to divide 7 by 1, x squared by 1, 6x by 1. In this example, it doesn't make a lot of sense because it's just the same thing, right? But later on, we're going to have a leading coefficient of something other than 1. So step 4 is to figure out what b divided by 2 squared equals. In this case, it would be 6 divided by 2, which gives you 3, and then you square that. So step 4 is, we know that b in this case is 6. So we have 6 divided by 2 gives you 3. And then when you square this, what is 3 squared?
9.
9. So this is going to be your magic number. Your magic number is used in step 5. Step 5 is to add b divided by 2 squared to both sides of the equation.
So whatever that answer to b divided by that b over 2 squared, whatever answer would be, is that what you divide?
That's what you're going to add to both sides of the equation. So you're going to add 9 to both sides.
Okay, so whatever b.
Okay, and since we're going to add b divided by 2 squared to both sides of the equation, I would recommend that you put a box on both sides of the equation. So I'm going to put a box here, and then plus 7 equals x squared plus 6x, and then plus some box. Okay, inside the box is where you're going to substitute in this value right here, the 9. Okay, so I'm going to add 9 to both sides of my function, both sides of my equation. So what's 9 plus 7? 16. Good. So you get 9 plus 7 is 16 is equal to,
X squared.
yeah, x squared plus 6x plus 9. Good. And if you notice, we have something that we can actually factor. So step 6 is to factor one side of the equation. In this case, it's the right side, by rewriting it as x plus b divided by 2 squared. Okay, so what is b divided by 2? Remember what b is? It's 6. So 6 divided by 2 is 3. So you really have x plus 3 squared. And if you notice, x plus 3 squared, which is what we were practicing today, is when you multiply x plus 3 times x plus 3. And when you simplify, you'll end up getting x squared plus 6x plus 9. That didn't make any sense. It is much better with students, okay? So I have a couple of students recording with me here, and their feedback was that it was really confusing how I went from x squared plus 6x plus 9 to x plus 3 squared. So going back to what we learned, so this is kind of on the side. If I have x plus 3 squared, which is what we practiced today in class, we are either using the box method or we could FOIL. So what's x times x?
X squared.
Good. And then x times 3?
X, 3x.
3x. Good. And then what's 3 times x?
3x.
3x. Very good. And then finally you have to multiply 3 times 3, which gives you positive 9. If I add my common terms together, I get 6x plus 9. X squared plus 6x plus 9 is the same thing we had originally. So it's a different way of rewriting the same thing. Remember, our goal is to change it from standard form into vertex form. So we're slowly getting there.
So x
right?
plus 3 squared, the vertex form.
X plus 3 squared, but we're missing the k. So now this is where step 7 comes in. Just add, simplify as necessary to step 6. We simplified by doing 6 divided by 2 gives us 3. Okay, and then step number 7 is to make the equation equal to 0 again.
So would you divide each side again?
No, how would you get rid of the 16 on this side?
Minus 16.
Yeah, you're going to subtract 16 from both sides. So when you subtract 16 from both sides, you're left with 0. 16 minus 16 gives you 0, is equal to x plus 3 squared minus 16. Ta-da! Okay, doesn't this look more like your vertex form?
Yeah.
Yeah.
You just don't have an A.
And we have to identify what A, H, and K are equal to. In this case, what's the value of A?
The value of A was...
No, look at,
Numero uno.
it's 1, right? So A is equal to 1, H is equal to negative 3, and K is equal to negative 16. Okay, so now we have finished going through steps 1 through 7. It is a lot of steps, but after you get the hang of it, it'll go by a lot faster. And what our goal was to rewrite a quadratic function in standard form into vertex form. So this is our final answer, and this is the vertex form of a quadratic function. This function and the original are the same exact thing. So if you were to graph both of these functions into your calculator, you would get the same graph.